So Unit 3 summary. And first of all, you need to know how to factor. So that's basically a way to solve a quadratic equation. Of course, the section 3.1 is only about factoring. Don't forget, the most basic idea of factoring is you find the common factor. See, there's a 3 as a common factor in 3x squared, negative 12x, and a 9. So you factor 3 out first, and then do the regular factoring of the trinomial. This one is factoring the binomials, but it is a difference of squares. So you can see, like this question, you have ax squared minus bx squared. So as long as you see the difference of squares, of two squares, and you can just simply use identify the first number, like in this case you still factor the 2, right? Factor the 2 out, so that's a common fact. And then you have 9 x squared and change to 3x squared. So eventually you identify the a squared minus b squared, and then your result would be a plus b multiply a minus b, right? And then if you know how to do the factoring, and then once the polynomial turns into an equation, right, just equal the polynomial equal to 0. And then if you can factor the left side and make it equal to 0, and then we just apply the zero product property to solve for x, right? The idea is very simple. So you treat x minus 5 in this case, and x plus 3 are different numbers. So they multiply together, and they must be either this one equals 0 or the other one equals 0, right? Because there's different numbers involve the same variable x. So they cannot be equal 0 at the same time. So this one or this one. Then you solve each one as a simple linear equation, you get a solution. Okay, and then section 3.3, and the equation just in a different way, and you may not be able to factor them, right? For example, if you get this equation, so eventually you change it into a very simple form. So you got x squared on one side and then the number on the other side. So you just take square roots. Now don't forget, it's positive and negative. So the two solutions. So that's a simple idea of take a square and then you solve for the x. And then what if the question is the ax squared plus bx plus c, and then you have this term compared to the previous one, and then you have to try to change this into a squares equal to something just like this. Of course, this is a simplified form, but we try to do the same thing, and to make it looks like you have a square on one side. If you look at the result, you would have x plus 3 squared, and then equals a number 14. And you treat x plus 3 just one thing, and then basically it's same as this, so that you can apply the same idea, take a square roots on both sides. So you solve the x plus 3 first, it equals to positive negative square root 14, and then you subtract 3 on both sides, so you eventually isolate the x, and you get two solutions, right? And then after you know how to do this kind of question, and you can actually apply the same idea of completing the square and apply to this general form. So you just take A, B, C as three numbers, and then you use exactly same techniques you used in the previous case. So for example, the first thing you do is you divide by A on both sides. So you change into x squared plus bx and plus c bx over a plus c over a equals 0. And then you should make up the third term and complete the square, right? But eventually, as a result, we develop this kind of formula, right? So we do use the same technique of completing the square and when develop this formula, right? So this is really something you should be able to do by yourself, okay? And then since we can figure out the formula, and really for the other question, we don't have to go through this process. So we just identify the A, B, and C, and then just plug in this formula to solve it, right? So that's 3.4. And finally, still we're talking about the same thing. So since we got this formula, and then there is a radical term, square root b squared minus 4ac. And it looks like this is a term that is decisive to our solutions. For example, if the b squared minus 4ac it's a perfect square, now in your solution you should not have the radical number because the perfect square will be gone. Change to its square root and it's a rational number. So, but that's one case. Now, basically, if this number b squared minus 4ac, which is called discriminant, is a perfect square, and then you should be able to factor the original equation in the first place. Okay, and then we define this thing is called discriminant, and if the discriminant is more than 0, and that means we have two real roots, because obviously you can tell from here. And then if it's equal 0, and it becomes 0, so plus minus 0, the two solution becomes the same. So that's why it has one only. And of course, if it's less than 0, then no real roots. So we already explained that. And you just try to, if you put these two things together, 3.3, 3.4, and 3.5, they're really talking about the same thing. Completing the square, we develop this formula, and then we use, we look at the b squared minus 4ac. We can really predict what kind of solution, how many solution we have. Okay, so that's all for this unit. You try to practice, especially the completing the square skill is a key skill, and then try to connect all these three sections. They're really just about the same thing. And even you can look at if this is a perfect square, you can actually connect this to the 3.2, because if this discriminant is a perfect square, that means your equation can be factored. Okay.